All right. Hello, everyone. Welcome to this quick session from HackerSpace. So basically, we have two things on the agenda today. In the first half, I will be talking about Git and GitHub and how to use them practically as a version control tool and for collaborating with other teammates. In the second half, Aditya will be talking about some useful tools and some useful techniques for working with Python. He'll be talking about virtual environments and notebooks. We feel that these topics are going to help you a lot when it comes to the hackathon that's coming up in a couple of weeks. So yeah, with that, let's get started. So first off, in this session, I don't really want to talk too much about what Git is or how it works, because I think there have been plenty of really good talks and really good resources pretty recently, both from within PS as well as there are lots of other resources. Reference, let me just drop a couple of links in the chat. There are some excellent talks about how Git works exactly. These are from PS open source, by the way, which is another club in PS. So I've just dropped a couple of links in the chat. Go through them whenever you want, and they're really good resources on the basics of how Git works, right? So what I want to focus on today is how you can practically use Git for working on your actual projects or working on your hackathon ideas and working with teammates, right? So that is what I want to focus on today. Just to give you a broad overview, Git is a version control tool. So what that means is you can use it to make changes to your code without losing the old content. So normally, like what you might do is make a copy, name it .old, something like that, right? So instead of all that, you just use a version control tool like Git, and it allows you to make changes while still allowing you to access old changes when you want to, right? Another interesting use of Git is as a collaboration tool. So, when you're working in a team and multiple people are working on a project, right? Git helps you to kind of organize your project, organize who's working on what, and who made what changes. It helps you understand all of that and work together quite well. So GitHub, on the other hand, is what is known as a repository store, right? So what that means is you have Git repositories on your system, which you're using Git to version control your code, right? And you can upload those repositories to GitHub to store them as well as share them with other people, right? So it allows you to store them and access them from other devices and so on. And at the same time, it allows you to share them with other people, can collaborate, and you can work with other people on your source code. Apart from that, GitHub also provides some tools for working with repositories. I don't think I'll be going over that in this session because that is slightly more advanced, and it's not essential for working with Git or working on projects. Maybe another time, but just so you know, GitHub also provides some tools to work with repositories, right? Let's just get started off, right? So I will be working on a terminal. If you're on Windows, so okay, I'll just repeat this. So how many of you guys actually have Git installed? Awesome. I think there are a few people. Good. So you can follow along with what I'm doing today if you want to just get comfortable with all the commands and stuff. If you're on Windows, you can use the Git Bash terminal. So just open up Git Bash and you should be able to follow along with all the commands that I'm using here. If you're on Linux, of course, just open up a terminal, and if Git is installed, you can just follow along, right? Normally, right? Just whatever I'm doing. All right. So I'll kind of relate this to how you might work on your hackathon ideas with your teammates, right? So it kind of gives you a good idea of what you might need to do on the day of the hackathon, and one day before the hackathon. Let's say, okay, now I'm going to start off with a brand new project, right? Empty folder, no code, and just starting off a new project. So let me call this HSP Git demo, right? So I'm just going to create a directory. I guess I should increase the font size. Probably not visible. Is that good? Is that visible to all of you? Bit more. Better? Awesome. Just creating a new directory. Let's call this HSB Git demo. So now I have a new directory. Let's enter that directory. Right? So now there's no files, nothing. It's an empty directory. Let's say this is the start of a new project, right? Do is you want to use Git and say that, okay, this folder is a Git repository. I want Git to store information about what changes I make here. I want Git to version control this folder, right? So for that, what we do is we run a command git init, right? So if I say git init, you can see that it says initialized empty Git repository in so and so directory, right? HSP demo git /.git. So if you can see here, it has created a folder called .git, and that is what it will be using to store changes and store the version history of all your code, right? So we are not going to be editing anything in that ourselves. Basically, like any Git commands that you run will modify stuff inside that folder, but manually we are not going to be doing anything with that, right? Okay, so now that we have a Git repository set up, the next thing we want to do is, of course, work on some files, right? So let me create a. You guys are probably bored of seeing this example, but yeah, hello world.c. Right? Okay, so I have a hello world program now. Let's say this is the entirety of my project, right? This is what I'm going to submit to Space Jam, right? So you can see that I have a hello world.c here. What's the next thing, right? Even on Windows, we can use nvim. You can install nvim on Windows as well. It's basically an editor. It's called neovim. There is a Windows version as well. If not, you can use practically any editor, like whatever you use, VS Code, Notepad, whatever you want to use, you can use it on Windows, right? So yeah, so now we have a brand new file. What do we do next? What we need to do next is we need to tell Git that, okay, we have a new file over here, and we want Git to track the versions of this file, right? We want Git to track changes to this file, store changes to this file, and allow us to go back in time, go back to older versions of this file and all that, right? So all I need to say is git add and the name of the file. So hello world.c, right? So when I say git add, what it does is it tells Git that, okay, now I'm tracking changes to this file hello world.c, right? Now, the next thing you want to do is you want to say that, okay, I have reviewed these changes. These changes are final. I want to commit them into history, right? So git add basically says that, okay, I'm tracking these changes. Git commit says, okay, these changes are final, right? So what I do is git commit, right? So a little trick, you can use this flag -m. So whenever you're making a git commit, right, you need to provide a commit message. So a commit message basically says what changes you have made for future reference, right? So when someone else is going through the commit history of your repository, they can look at the commit messages and understand, what changes were made in a particular commit and so on, right? So you can just directly give the message here using the -m flag. Otherwise, you can just say git commit and it will open up an editor for you. Whatever editor has been configured by default, it will open up an editor. So you can just, type in the message over there and save and close it, and it will use that as the commit message. But for now, I think this is fine. Let's just say added hello world, right? So you can see that it gives me a little message. Can you please repeat what -m does? Okay, so what -m does is it basically allows you to specify the commit message in the command itself. So in fact, let me just give you an example of what it might look like otherwise, right? Let me just create another file called for now. This is some, right? So as usual, I will just git add test.txt, right? And now I'll just say git commit, right? I won't add the -m flag. So what you can see is it has opened up my editor with this kind of layout, with this kind of template, right? And what I can do is I can say, I can enter my commit message here, right? So I can say, this is the second change. And I just save and quit, and it has used that as the commit message now. So usually what you when you're working on large projects, or when you're contributing to industrial projects, you are expected to sometimes follow a certain template for your commit message, or sometimes you're expected to write slightly more descriptive commit messages, right? So where you're explaining in a little more depth what changes are being introduced in the current commit. So in those cases, it's nice to have an actual editor to type out the entire commit message. But for now, for our purposes, I think using the -m flag and just a short commit message will work fine. That is what it does. And now you can see that there is some message over here. It gives me the commit message. This is the second change, right? And it tells me what has changed, one file changed, and one insertion, right? So there haven't been any deletions, there haven't been any modifications. There's just one insertion. And it says it created mode. This basically means it created a new file called test.txt, right? And that's all as we expected. So yeah, this is the basics of how you do version control with Git. Now, there are some things that you should know while you're working, right? So for example, let's say I make a change to one of the existing files, right? So let me make some modification to hello-world.c. Int a is equal to 2. Just some random examples. Right, we have a couple of changes. And now, to track, like to get an idea of what changes have happened since the last commit, right? I can say git status, and you can see what it says. It says on branch main, changes that are not staged for commit, hello world.c, right? And it says that it has been modified, not created, it has been modified. And it in fact just gives me the command over here as well. It says use git add file to update what will be committed. And this is the part that I want to talk about now. Use git restore file to discard changes in the working directory, right? So let's say that you have made some changes. Okay, let me just cover some questions that have popped up in the chat. How to change branch from master to main? All right. So if you are using a modern version of Git, one of the later versions of Git, it will automatically create a branch called main instead of master when you create a new repository, right? If you're using an existing repository which already has a branch called master, it's safest not to change it, because consider it. There are a lot of places which would require it to be master, so changing it is not trivial. But if you're using a more modern version of Git and you're creating a repository for the first time, it will automatically create a branch called main instead of master. Isn't it supposed to be %i and not %d? I'm pretty sure it's %i, unless I've forgotten C and C++. How to add multiple files? File names, comma separated or space separated? They will be space separated. So for instance, let me just do that now. So I'll modify test.txt also. Right? Now we have two changes, right? So if I just say Git status, you can see that there are two modifications now, and I can add both of them together. Git add hello world.txt and hello world.c and test.txt. I can add both of them together, right? All files can be added using git add dot. Yes, that is also available. Suggest being slightly careful when doing that, because you might occasionally add certain files which you may not want to add to version control. Have things like environment files which hold secret keys. Sometimes you have some temporary files that are created by your editor, and you generally don't want to add all of those. But if you're sure that you want to add all the changes to version control, you can just use git add dot, and that adds everything, right? Git add dash a for that. So yeah, coming back to this, I can say git add the two files. It has added the two files, and now if I run git status again, you can see that changes to be committed, right? So I've added them now, changes to be committed. It still says git restore dash staged file to unstaged, right? So this is what I want to show you now. Let us say that you have made some changes, you have added it already, but you don't, you then go over those changes and you think, okay, I don't want these changes, right? I don't want these changes to be in the repository. I want to remove them, right? So what you do is git restore dash dash staged. Let's remove the changes to test.txt, right? Test.txt. So when I do that and I say git status again, you can see what has happened. It hasn't reverted the changes altogether. What it has done is it has removed it from the commit, right? So it says again over here, changes not staged for commit, use git add file, right? So now if I want to add those changes again, I can say git add test.txt once again and add them back, right? But now it has basically removed it from the commit. If I want to remove the changes altogether, if I want to, reset the test.txt back to the state it was in the previous commit. So let's just take a look, right? So we have another modification, right? We have this line which is added after the previous commit, right? So let's say I want to remove that. I don't want that. I want only the first line. This is some additional content, right? So what I can do, say git restore test.txt, and it resets it to the previous version. So now if I open test.txt, you can see that the second line has been removed. There's only the first line, right? So yeah, that is restoring. So restoring is quite helpful because, as I said, quite often you might add certain files or commit certain files which you did not intend to commit. You may not want those changes in your commit or in your Git history. So in those cases, you can use git restore to remove them from your commit or remove them from your staging area. So I'll take a small break over here and go over the questions, because I think there have been quite a few questions. All right, I think this was the last one I did, how to add multiple files, right? What do you mean by commit? Okay, so yeah, for this, I'd actually suggest you go over the links that I sent earlier. It sort of ties into the basic idea of how Git works. But just to give you a brief understanding, you can think of it as there are two levels, right? There is something called a staging area, and there is something called, wait, let me see if I can just pull something up and draw it, right? Okay, never mind. So yeah, so there's something called a staging area and there's something called your commit area, right? So when you say git add, you're basically adding the file to the staging area. And what that says is, I want to track these changes. I want to track any changes that happen to these files, right? And when you commit something, it says that, okay, I take all the changes that are in the staging area. I have reviewed them. They are stuff that I want to add to my Git repository. I'm committing them into the Git history, right? That is what the commit means. Add, you're adding it to the staging area. And when you say git commit, you're taking from the staging area and adding it to the commit, right? Can you elaborate on how to make use of master and main branch? I probably do not want to cover branches right now. I might do it maybe towards the end of the thing. But the thing is, by default, Git provides one branch for you, right? So in older versions of Git, that would be called master. And in the newer versions of Git, that will be called main. And for now, I think it is fine if you just work on that branch. Maybe later on, I can show you how to use different branches and all that, because then I'd have to go into merging and all that, which is slightly more advanced. But yeah, what the main thing is, Git provides the default branch, and you can use that to work on all your projects, right? Mind opening hello world.c again, sure. Yeah, so you can see that the change I made here is still there, right? Commit. Does git add file name act as a commit too? No, it does not. As I said, git add file name just adds it to the staging area. So it means that it's tracking changes to that file. And when you do git commit, it takes the changes that are in the staging area and adds it to the commit. Anil will cover about git ignore soon. Yes, I will. I get a warning. LF will be replaced by CRLF in hello world.c. Right. So this is something you might see. It is mostly harmless. So this is mainly something, it's a Windows to Linux conversion kind of thing. So basically, when you press an enter, you get a new line, right? So a new line in Windows is represented by LF, which is line feed. Linux is represented by CRLF, which is a carriage return followed by a line feed. So I think Git by default tries to store it in CRLF format when you add it. So it should not cause any issues. So that's just a warning. It's just like a Windows to Linux conversion thing. Can you please send a command list after this session? Yeah, sure. I can send you the commands that we cover in this session. But there are quite a few references online, and the links that I sent earlier also have a few of them. That commands, yeah, commands will be sent. What do you mean by commit? I hope I've explained sufficiently what a commit is. I mean, do drop a message if you want me to elaborate a little more. So you can restore the changes to the previous commit after you have added them, but not after you have committed them. No, you can restore them from the commit also. Like even once you've committed them, you can still restore them. Print work, git restore dash dash staged work. Right. So as I said, once a file has been added to the commit, right? So let me just show you. So yeah. I have a change here, right? So now if I say git status, you can see that there is one change to be committed, which means it is in the staging area. And there is one change which is not staged for commit, right? So if I want to restore a file which is in the staging area, right? So I want to unstage those changes, basically. I want to remove those changes from the staging area. Then I use git restore dash dash staged. Whereas if I want to restore the changes that I made, which are not staged, and I want to undo those changes, I want to delete those changes, and I want to go back to the old version of the file, then I just do git restore file name, right? So again, quick warning that it actually gets rid of your changes, right? You won't get, there's no way to get them back again when you do git restore back to the old version. %d. Yeah, that's what I said. I'm pretty sure it's %d. Or is it %i? Okay, it's %d. I hope I'm right. For okay, you know what? We can discuss C a little later. Right. So yeah, so we did cover Git Reset. Sorry, Git Restore. Probably another thing, slightly related thing is a command called Git Reset. So let me just show you that quickly. So what I will do is I will add the new change that we made as well, right? So now if I say git status, you can see that we have two changes to be committed, right? So now we have two files, helloworld.c and test.txt, which are both in the staging area. We want to remove all the changes that are in the staging area. We want to unstage everything, right? We want to unstage everything. Up to what point? Let's say we want to unstage it up to the previous commit, right? So we whatever changes are made in the previous commit, we want to stage the changes up to that point. So for that, what I can say is I can say git reset head, right? So what head is, head points to the last commit that was made in your repository. So in our case, that is just the first commit that we made, right? So if I say git reset head, you can see that it unstaged two files. You can see the message that gave here, unstaged changes after reset, helloworld.c and test.txt, right? So now if I just do a git status again, you can see that these two files are no longer staged, right? There is another command. I don't know whether to show it to you or not. It's slightly dangerous. Okay, I just skip it. It's maybe we can discuss it later. So one last thing that I want to show you. So what we'll do now for this is, let us just add these two and create a commit. Right? So we have added it. We have added a commit. And now if I say git status real quick, there's nothing to commit because everything has already been committed, right? Now let us say I want to undo the changes that have been made to the second file test.txt. Let's say I want to send it back to the version that it was after the first commit. So let me just show you something real quick. You don't need to know exactly how to do this. I will share it with you later. But this is basically just a visualization of your commit history, right? How it looks. Added hello world. This was our first change. And we have okay, that is actually the third commit, my mistake. So we have three commits basically, right? So you can see how it looks, right? And as I said, head is the last commit that was made to a repository. So now we can see like all the changes that were made, right? So now let us say I want to reset the changes that were made to test.txt back to the second commit, right? So what I can do, so what you need to do is, just make note of this number, right? This small hash that is given here, 0590C37, right? So what we can do is we can say Git Checkout, then the commit number, right? 059, whatever we saw, followed by a dash, followed by the name path, right? Which was test.txt. Did not match any files known to Git. Did I make a mistake? I'm pretty sure that's what it was. Just give me a sec here. Yeah, so the reason I did not prepare for any of this is because I wanted to see the kind of mistakes that you might make, and it's pretty easy to fix, right? Let us see. Okay, I probably did not need this. Does that work? Yeah. So yeah, if you see test.txt now, it's back to the state that it was in the second commit, right? Yeah, so my mistake that I think I was using an old syntax or something like that. Yeah, so that is what I wanted to show you about Git Checkout. So if you want to undo the changes to one specific file, you can do that, right? To do that for the entire repository, just do Git Checkout the commit number without a file name, and it will check out all the files to that commit, right? So this is basically like going back in history. Once again, quick warning, things like this quite often will undo all the changes that you have made. So make sure that it is what you want to do, and preferably, make a copy somewhere so that you don't lose any changes that you don't want to lose, right? Once again, I'm going to take a quick break and um, take a look at the questions.
1 second, the glog, it doesn't work for
Yeah.
Git Bash. Glog doesn't work in Git Bash.
Yeah, I did tell you that because that is something custom that I have over here. That's just a visualization that I was using to show it to you. I will share the command that I used so that you can use it later. Um, but that's basically just a visualization. Let me just. Uh, okay, so yeah, so this is the command I'm using. I don't know if you actually um, copy and paste it in the chat. I will share this with you later as well. But if you're interested, you can just try this out. I'll put it in the chat. Um, okay, lots of people talking about C. What is the command he used? Yeah, I just shared that. Um, yeah, git log is the basic command. That is the the base command that is used to generate all of this. Glog is something custom that I have. And with you should be a pretty good approximation of that. The commit number is 10 times longer. Yeah, the full commit hash is pretty long, but generally for all these operations, you just need like the first 6 or first 8 digits of the hash to uniquely identify that hash. So a lot of times, if you use like there are flags to have a shorter log, and they will only give you the first 6 or 8 digits that you require to actually use it in a command. But the actual hash number will be pretty long. When will the recording be released? Sometime after, probably by tonight, maybe by tomorrow morning. Um, how to get the checkout number? Yeah, so as I said, just use git log. You get the commit numbers, right? I also get tab completion. I don't know if you get that on Git Bash, but I get tab completion for the commit numbers as well. When I use a commit when I use a command like git checkout, it gives me tab completion for the commit numbers. Git log is customized and not default in Linux. Yeah, it is not default for Linux. It is something that I have. It's something custom that I have. All right. So let us continue now. So this is all I had to show you about working on Git, right? So this is what I wanted to show you about working on a project with Git. Is how do you work with GitHub, right? How does GitHub link into this? How do you work with GitHub? How do you work with your teammates on GitHub? That is what I'm going to show you now, right? So let us quickly switch over into a browser, right? Um, and go to GitHub. So as I said earlier, you need an account, a GitHub account to follow along at this point. I'll give you a couple of minutes to, if you want to follow along, just to create a GitHub account if you haven't done it already. So yeah, so just to give you an overview of what we'll be doing on GitHub, we will be uploading our repository that we created to GitHub, showing you how to sync changes onto GitHub, and I will also be showing you how to work with teammates on GitHub, right? Wait, what? Are you the only person I follow? No, you're the only person who actually does stuff on GitHub. Okay, see, I found one more person. Yeah, I'm pretty sure I don't think like pretty much everyone else I follow haven't started these many repositories combined. All right, so let me just start off. So once you have your account, right, you should be in a page which looks similar to this. Is go over to this new repository, and it gives you this dialog, right? So the owner, all this should be default. Repository name, let us call it HSP uh, Git demo, right? So yeah, you can provide an optional description if you want. Git and GitHub demo for HackerSpace, right? So let us keep it public for now. I don't know, should we keep it public or private? Yeah, let's make it private for now because I want to show you some stuff about having private repositories. So basically a private repository is not available for everyone to view on GitHub. It's only available to you and who you choose to share it with. Whereas a public repository is available to everyone. So generally with an open source project or something that you want to get collaboration from lots of people on, you make it public. Whereas in general, for a hackathon or something of that sort, you probably want to keep it private and just collaborate with your teammates, right? I'll show you how to do that. But at least for the duration of the hackathon, you want to keep it private. So when you're creating it, just make it private initially, right? You can of course change this later on, but when you're creating it, we'll make it private. We don't want to add a README file. We don't want, because we'll be doing all this manually, right? So just leave this all as default, create repository. So once you do that, you should be on a page like this, right? So just to let's make this HTTPS for now because I don't want to show you how to set up SSH keys and stuff. But yeah, so just choose the HTTPS version, right? Now what we want to do is we want to sync the repository we have on our system to this online repository, right? Is we just copy this this path, right? It gives us a certain path, https github.com/your username / the name of the repository .git, right? So we'll just copy that, go over to our repository over here, and we run this command, right? Git Remote Add. We need a name for this, so let's call it origin because that is kind of like a default, and we just paste in the path over here. So let me just break down what is going on over here. Git remote is basically a command which allows you to sync your local repository with a remote repository. That remote repository might be anywhere. It need not be on GitHub. You guys might have heard of other repository stores. There's this thing called GitLab. There's something called SourceHut. You can even create your own Git server, right? But yeah, Git remote basically allows you to sync your local repository with any remote repository. And we are adding a remote. That is what we're doing, and we're giving it a name. So by default, the name given is origin. So that is what we are going to be calling it as well. And we give it the URL to the server, right? The online repository. So if I just run this command, following that, I can just say git remote and it will show me what I have configured, right? So you can see over here, it gives me two things, right? It says origin, the URL that I just added for fetch, and origin for push, right? I'll probably tell you what that is in a little bit. But what we want to do next is git push origin main. So what this says is whatever changes we have, whatever commits we have on the local repository, right? To the remote repository called origin, and we want to push the changes that are on the main branch, right? So this is the name of the remote repository, and this is the name of your branch. So once I do that, it takes a moment. You can see that it gives you a progress report, what's going on. So yeah, so you can see here that it has created a new branch on the remote repository, right? So what it did is we have a branch called main on our local repository, but we don't have it on the remote. So it created a new branch called remote on the main, and now they're tracking each other, which means whatever changes you make on main over here, and you just say git push, it will push it to the main branch on your remote repository. So now if I just go back over here and refresh this page, you can see the changes that we made, right? Access, okay, this is an extension that I have. Let's ignore that for now. Yeah, so you can see that we have the changes. Error, failed to push some refs to couple of reasons. You might have internet issues, that is one thing, but if you're on call, that's probably not the issue. Another possible issue is sometimes Windows pastes some random characters into your thing when you paste in a terminal. Just try typing out the URL instead of pasting it in. It might work. You're on Linux, but yeah, still could be the same issue. When you paste into terminal, sometimes there are some 0-bit characters and stuff which get pasted for some reason. So just try typing it out, it might work. Right, so if it all worked fine, you should be seeing something like this. Whatever changes, right, you can see what commit it was, you can see the files. I can just open it up, it's all the same, right? So yeah, now we have our local repository synced with the remote repository on GitHub, right? Now, how do you sync changes, right? So let's just create another change over here. Let me modify hello world.c. Let's say int a is equal to 3 now. Breaking change. So let me add that and let us commit. About these commands that I'm using, they're something custom that I have set up. It's basically the same thing, Git Commit Dashboard. This is the fourth one, right? So now we have a change that is on our local repository, but it is not on the remote repository. So if I say git status, it should show up. Working technique. Okay, it does not show me. Anyway, okay, I guess I should have probably set it up as, yeah, they are shortcut commands that are configured on my system. So once again, I can say git push. Note that I'm adding a flag -u this time. The reason I'm doing that is because I want to say that the so the reason I'm doing this is because I want to say that not master, this is main, right? The branch main on the remote should be the default branch to push to for the local branch main, right? So the -u flag says set upstream to, which is basically setting this as the default. So once again, it will take a moment. Right? And you can see that this time it gives me a message saying branch main set up to track remote branch main from origin, right? That's what we wanted. Now, so if I just refresh over here, you can see that the latest change came up as well. Int a is equal to 3, right? So that's what we expected. So once you set up the remote, right? If you're using an older version, should I write master? Yeah, you should probably use master. So what you should probably do is just type in this command git branch, right? So it should show you the branches that you have. By default, you should have only one branch. For me, that's called main. For you, it might be called master. So whatever name you get here, that is what you should be using. You are still getting the same issue. That is odd. I cannot think of anything else right now. We'll probably debug that a little later. Right? So yeah. So now if I make another change, right? So now that we've set it up as the default, if I make another change, let's just make this 4. I'm running out of ideas to make changes. Git add, git commit. So now if I say git status, you can see that it now knows that we have a remote, we have a branch on the remote repository, and it can compare between the two, right? So it tells me your branch is ahead of origin/main by 1 commit, which we just made. Use git push to publish your local commits. And the cool thing now is you can just say git push. you do not need to say origin master because you have already configured origin main to be the default branch, not master origin main to be the default branch, right? So I can just say git push, and it adds that change, right? So if I just refresh over here, you can see that a is equal to 4. All the changes are working good, right? So the next thing I want to show, okay, mine was master, that was the issue, right? Yeah, so just main is on slightly newer versions of Git. You might have something called master. The branch might be called master. So just be careful, right? Right. So the next thing I want to show you is how do you work with teammates, right? You have 3 teammates or 4 teammates. Okay, I don't think you have 4. You have like 2 or 3 teammates, right? And you probably want to work on the same repository at the same time, and you don't want to clash, you don't have issues or anything of that sort, right? So what we're going to do here is we are going to add your teammates as collaborators. So a collaborator basically has access to view your code as well as make changes to this repository, right? So for example, if you guys try to push any change to this repository, to any hm136/hsp git demo, you won't be able to do it because you are not collaborators. So what I will do now is just you can see that there's a tab called settings. I just go to settings, and we have manage access, right? The second one. Just go to manage access. So you can see there's a button called invite a collaborator, right? So you can just search by username. I'm just going to add Aditya over here, right? So it sends out an invite to him, and when he accepts, he will be able to view this repository as well as make changes to this repository, right? So Aditya, real quick, can you just accept this and make a change to this repository?
Make a change.
I'll just show them how to pull in a change that has been made.
One sec.
Yeah.
I accepted the change. Yeah.
What
I can okay, fine.
Yeah.
I thought about accepting the changes while doing my virtual environment stuff.
No, just make a change so that I can show them how to pull in the change.
1 second then. I'll just add a readme then.
So, yeah, sure. So basically what we're trying to simulate here is, let's say you're working on something, right? And your teammate is working on something else, they make a change, how you might sync them together, right? Meanwhile, let me show you one more thing. As Aditya mentioned in the chat earlier, there is something called a Git Ignore, which you should know about. So let us say, as I said, right, when you use something like git add dot, right, it adds all the files that have any changes to them, right? Sometimes there are some files which you don't want to track. There might be, some editor files, some temporary files, something of that sort. You might not want to track them, but then you might have like 100 files with changes and only 5 of them are junk, right? So it would be much more efficient to just do git add dot and not add all 95 of them separately. What you can do is you can maintain a file called .gitignore, right, in the root of your repository. And what that does is it maintains a list of patterns to ignore when you're adding, right? So basically those files are ignored by Git when you're performing any Git actions. So let's just create a quick Git ignore. So it will be called .gitignore, right? And let me just add some file, junk.txt, right? So we have a Git ignore now, and let me just create another file, right, which matches the pattern that I just added to the Git ignore. To be in our Git history, right? So if you can actually see already, right, if I do git status, you can see that it is only showing git ignore as the untracked file, and it is not showing me the junk.txt is an untracked file because we have junk.txt in our git ignore, right? So it's as simple as that. You can in fact even add patterns. So for example, if I change this to junk star.txt, it will match anything, right? So if I junk1.txt, junk demo.txt. See, none of them are added, right? Because it matches the pattern. As simple as that. So that would be quite useful. Okay, I see that Aditya has added a file. So let's just take a quick look at it on GitHub. All right. So I see you added in the Python file. Very nice. Right. So we have hello-world.py, right? So we have an additional file now on a remote repository. So this could be something that one of your teammates pushed in, right? And now you want to sync these changes to your repository. So what has happened now is you have some additional changes on the remote, which are not on your local repository. In this case is you want to do something called Git Pull, right? We might actually hit an issue here, and I want to show you that. If not, doesn't matter. So Git Pull, the syntax is again quite similar. Git Pull, the name of the remote, origin, and the branch, which is main, right? So you can see that I did some stuff, remote enumerating. It pulled in all this stuff. Fast forward. Okay, so what a fast forward means is that there were no conflicts between the changes that you had and the changes that were on the server, right? Basically just created hello-world.py, one file change, one insertion, all that is fine, right? So if I see over here now, we have hello-world.py on our local repository. Hello-world.py, right? Whatever he added, we get it over here. So this is how you sync changes that have been made onto the remote repository by someone else, right? This could be your teammate. Right. So that is pretty much all I had to say about Git and GitHub today. Before I close, I just like to go over a few safety measures, as it were, because a lot of time, especially when you're starting out, there are some commands which are slightly risky to use, and it might loss of changes and stuff. So few points. Always want to commit before pulling. So this is something that I did not do over here, and I was hoping it would hit an error so that I could show you, but anyway, it didn't. So what you always want to do is, if you have any changes on your local repository, right, you want to commit them before you pull changes from the remote repository. The second thing, always pull before pushing. In fact, GitHub doesn't even allow you to push without pulling in previously, right? So for example, if there are some changes which are on the remote repository which are not on the local repository, you cannot push any changes that you have made, because your local repository has to be up to date with the remote repository changes, right? So a general guideline is to work on different parts of the project. So just decide beforehand who's going to be working on what, and work on different parts of the project, so that you don't have conflicts. And if you do that well, all of your changes, there will be fast forwards like I just showed you, right? Copy. So quite simply, there are a lot of commands, as I said, which can cause loss of data. So if there is any command that you have even a small doubt about, or there's a small possibility of losing data, just make a copy of your folder, just copy your folder somewhere, and then run the command, right? So worst case, you still have your changes somewhere. Right, so that is all I had to say for today. I hope you all learned something today, and I hope it will be useful for your hackathon. As usual, if you have any queries, drop them in the chat right now. If you get something later on, you can drop them on Discord, and we'll all answer them, right? Yeah, so thank you. I'll just spend some time answering a few questions, and then Aditya will take over to the second part of today's session. Right. This isn't the web page I'm looking for. What web page were you looking for? Where do I find the invite link if someone sends me an invite? Yeah, you should get an email, as Aditya said. You will get an email to whatever email ID is linked with your GitHub account with the invite link. So you just click on accept, and it will give you access to the repository. What happens if you make if you change things in local and don't push it, and your friend makes changes and pushes it, if you pull, it will merge your local copy and the GitHub copy. Yes, this is actually something that I did not want to go into today because it is slightly complicated, merges and merge conflicts and stuff. So that is why I suggest that, you work on different parts of the project so that you don't run into this. But yeah, in general, what it does is it tries to merge the changes that you have as well as the changes that are coming in from the remote repository, right? Changes are sufficiently different. For example, if you have a change in the first line and someone else has a change in the last line, Git is probably smart enough to actually combine them and give you a proper file. But if they're close by, or there's slightly larger edits or something, it might result in something called a merge conflict. And what you would have to do then is manually identify what changes of yours you want to keep in the file and what changes from the remote you want to keep in the file. So I don't really want to go into that. Of course, there are plenty of resources online. It's called a merge conflict. You can look it up. Definitely, you should try to avoid them. How can I get the file from the collaborator into my PC? As I showed you, so your collaborator would have to push their changes onto the remote repository, and you would have to pull the changes onto your local repository. This video is yes, this video will be uploaded once we're done.
Okay.
Git clone. Oh wait, I did not show you Git clone. One sec, I forgot to show you Git clone.
Okay.
Right.
I was supposed to do that.
Yeah, okay. So Aditya will show you Git clone as part of the Python session, right? He will continue working on the same repository.
Yeah.
So yeah, Aditya, all yours.
Okay, cool. So let me start sharing my screen. So hopefully all of you did understand how Git kind of works. It's not everything. We've barely scratched the surface. There's a lot more to Git and GitHub as well. But for now, this will kind of do. Can you guys see my screen? Can you guys? Okay. Okay, so I'm assuming everyone can see my screen. So taking that into consideration, let's just move on. Okay, so we're going to talk about virtual environments. Okay, so the first question is, why do we need virtual environments, and mainly what is a virtual environment? Now, let's take a hypothetical situation, or let's say in future situation where you're a developer who's just learned how to code and you just learned about version control, and you basically want to use all these tools that you have learned and you want to start working off on projects. Now, I'm pretty sure this is something that you will face even in the hackathon soon. So thing is, you would probably start off working on multiple projects at the same time. In fact, if you saw the GitHub feed which Anirudh opened up, you could see the number of projects I'm simultaneously working on. So there are a lot of projects which you will be working on at the same time. Sometimes 5, 6, 7, 8 goes on. So now the thing is, more projects obviously means more stuff for your GitHub, but it also creates more issues. Okay, but thing is, what exactly are these issues, and what do you mean by issues when you're sort of working on a project? Because I mean, what could possibly go wrong, right? Well, it turns out a lot of stuff can go wrong. Just to give you an idea of what can go wrong, we're just going to quickly go through a simple story. So your name is Peter Parker and you are working on a very cool project, and you keep working on it, and you kind of hit a roadblock. Okay, because you realize that, okay, I need to implement something in my code, but I cannot implement it. However, there are ready libraries that are available which I can sort of pip install and use these libraries for my support. An example of these would be machine learning libraries, deep learning libraries, and so on. So yeah, you do a bit of searching, you scan through GitHub, do a little bit of Googling here and there, and you find a good number of libraries that you can use. And what you do is you quickly install it and you think, okay, I'm done, right? Because it's working very nice, no issues at all. But that's not actually the end of everything. Suppose these are the libraries that we'll be installing. Don't worry about what these libraries are. There's Django, there's Stripe, NumPy, and AWS SDK as well. So you observe that these are the libraries that will be required to sort of make your application run in a way. Now, you started working on another project, okay? You started working on another project and you see that again, you sort of cannot build the project on your own. You're heavily reliant on these libraries, it seems. And okay, you're like, okay, fine. I mean, what could possibly go wrong? I installed it before, let me just install it again. And that's what you again do. Again, you do the same process. You do a bit of Googling, you scan through GitHub repos, and you finally find a particular implementation of a library that sort of works for you. And you think that's it. Okay, I have two projects working perfectly now, and no issues at all. But that's not the issue, because you see that project 2 does not run. Okay, because it always gives some kind of error. It throws up an error. I'm not going to go into what the details of these errors for now, but basically it won't run at all. You'll probably get something like this does not match with that. This does not match with that. Now just keep this error kind of in mind. So you kind of give up on project 2 because you see that, okay, I don't know what to do, right? Because everything is installed and it was working, and now I don't know, it's not working. So you're like, okay, fine, let me just, switch back to project 1, keep working on that because that was working kind of. And, you'll think about project 2 later. But the biggest issue is you see that now project 1 also does not work. And now you'll be like, okay, how? Why? Why does this happen? Well, a simple reason for this happening is something known as dependency conflicts. Okay. So Peter had installed, different versions of the dependency libraries that he had used. For example, let's say project 1 required Django and project 2 also required Django. Now, the issue is what Peter did is he was running project 1 using Django 2.7, and all the other dependencies in project 1 required Django 2.7. Now, when Peter moved on to project 2, he had to sort of, install other libraries which kind of required Django 3. And the moment this happened, Django automatically upgraded itself to project 3 to kind of make it run. But sometimes what happens is not everything upgrades by default. It's very rare that, everything will by default sort of upgrade itself to match the version. If you're lucky, this actually happens, but most of the cases it does not happen. Most of the cases it just installs what it needs. And so what ends up happening is for project 1, you have a few library versions for project 2. And in project 2, you have a few library versions for project 1. So at the end of the day, none of the projects can run because the versions of the libraries that are required for your projects don't match. Are you guys following so far? Like, does this make sense so far? A simple yes or no would help. Okay, so basically, if you haven't followed the story so far, what I'm trying to say is different projects will have a different list of dependencies, all right? And what might end up happening is the dependencies of a particular project might not work with another because, the other project might have a completely different list of dependencies. In fact, it's just not about dependencies. You'll see later, it can go into versions of Python as well. So yeah, one of the easiest fixes is obviously to uninstall every single dependency and install again one at a time. Now, obviously this is not feasible because it means you can only work on one project at a time. But does that mean you only work on one project at a time? The answer is no, obviously, because you can't really do that. So the way you do this is you sort of create something known as a virtual environment. A virtual environment is basically like a small runtime platform or or a runtime environment where your application will run. Okay, so instead of running on the system itself, that is your system Python, what you do, you create a smaller Python runtime within your system Python and you run it on that. So what ends up happening is every time you need some kind of dependencies, it will sort of check for the virtual environment's dependencies instead of the entire system Python's dependencies. So this is what I'm trying to say. For example, I don't know, I just ripped this image of Google Images, but apparently there's this library called Ansible, and let's say you need 3 environments. you can sort of, install different versions of the same library for your different environments based on the project that, you're working on. And you can actually extend the idea of virtual environments to Python versions as well. In fact, you can have multiple versions of Python for the same main version. That is, you can have 3.5 as well as 3.8 and 2.7 as well if you're working on some old projects. Nowadays, you don't really need Python versioning because almost everything has been kind of sort of transferred over to 3. But a lot of these issues were there, especially a few years back. Okay, when I mean a few years back, it was actually 2-3 years back, because for all of you, who are interested in machine learning, deep learning, so currently the version of TensorFlow is TensorFlow 2. Before that, there was TensorFlow 1, and almost everything was written in TensorFlow 1. In fact, there were few papers or implementation of papers that were written, that were made in 2016, 17, that were still written in TensorFlow 1. And only recently did people start, sort of, what do I say, transferring everything to 3.6 kind of. So yeah, TensorFlow 2 kind of perfectly works with 3.8 as of now. In fact, 3.8 also is kind of a stretch, because I remember 2 years ago, or roughly not 2 years ago, towards the beginning of my second year kind of, even 3.8 was a stretch. I remember using 3.7 and 3.6 because that's the only thing TensorFlow 2.x kind of completely supported. And yeah, as someone said, 3.8 perfectly works now. So yeah, 3.8 does work, so there's no issues about that right now. 3.8 kind of gained proper support, I think, last year or something. So yeah, that's what. Python versioning is, although rare, is used in a lot of places. Most of the times you don't really need Python versioning, and I won't be focusing on that in today's workshop. So yeah, you can also mix and match however you want. I'm not going to talk about this as well. This is a bit complicated to set up because you would need your runtime environment to use dependencies from your system. This is a bit complicated, but we are not going to go into this. The only thing we will be talking about is this one, that is the different dependency environments. Apart from that, this is a tip, okay. We'll be doing everything manually using something called virtual environment. But there is also something known as Anaconda. Anaconda will not be covered right now, probably in a later workshop or session right after your hackathon. But Anaconda is like a graphical user interface for managing virtual environments on your system. It's a really nice tool to use, although it is extremely heavy to use. And that's the reason people don't really prefer Anaconda, because it kind of brings with it a lot of baggage which you will never use. Like 90% of the stuff it brings along, you never really use. So people prefer doing it the manual way right now. But yeah, if you're new and you don't really want to use the command line, Anaconda is a very good tool. It takes a ton of time to install and set up, so let's not do that now. Don't get too curious right now. Okay, so now we're going to look at how to exactly manage virtual environments. I'm quickly going to like move over my, hopefully you guys can see the Ubuntu screen. Hopefully you guys can see. I'll just log in. Okay, so yeah, so basically what we were doing is we were sort of working on the same repo. Yeah, as Ani said, Miniconda is also there. So we were working on the same repo which Ani had set up. Git clone this thing. So yeah, if you're using HTTPS, you will probably need to set this up. Thing is, I just installed Groovy Gorilla today, so it's not set up. So I just hope I don't run into bugs now. Yeah, so as you can see, this is how git clone works. So git clone followed by the URL will clone your repo onto your local system. And once I sort of cd into the repo, you can see that all the files are there. And yeah, so as you can see, the hello world.c file is there. Okay, so now what I'm going to do is I'm going to actually work on the thing. That's not. Okay, so yeah, I'm going to use VS Code like a normal person. So once this does load up, Yeah, so as you can see, this is the repo. There's nothing really there in the repo right now. Okay, so what we're going to do now is we are going to set up a virtual environment and look at how exactly a virtual environment helps us. Okay, so now before that, let's just quickly look at what Python version we are using. Okay, so assuming we're in the home directory, if you do which Python 3, you'll see that it prints the system version of Python here. All right, but now the thing is, you don't really want to use the system version of Python. Instead, you want to use a virtual environment for that purpose. So what you can do for that is you sort of go into the directory where you are working. You can actually use any directory, but it's kind of like a norm to actually initialize an environment in the root directory of your project. So you do something called virtual env. Virtual env is you need to like sudo apt install it. I think it's sudo apt install Python 3 virtual env. So you need to do virtual env followed by the name of the environment which you want to make. So I'm just going to call it HSP demo for now. And it will take a bit of time to kind of initialize the environment. By default, it will use the same Python version as your system. Okay. So the reason it does this is because it does not find any other Python version available. But if you have multiple Python versions installed, that is, let's say Python 2 and Python 3, or Python 3.5, 3.4, and so on, you can actually specify the version. Right now, I'm not going to talk about that because most of you will be working on the same version of Python, I'm assuming. So once you've done that, you will probably see a folder that's been created here, which contains the environment itself. And if you can see, there's already a Git Ignore, which is present here. This is, as you can see, this is by default created by virtual env. So yeah, it automatically handles environments for you so that no environment files are pushed onto your repo, which is kind of really neat because you don't need to manage it directly. So now that you do have that, the question is, how do you actually use the environment? Simple way, you do something called source. Oh, by the way, this is a Linux command. For Windows, it is a bit different. I am not really sure what the Windows command is. Sorry about that. But I do have a really nice tutorial about virtual env and how to use it. Probably after the workshop, I will share the link for that. So what you do is you do source and HSP demo, and you need to go into your bin folder. Now your bin folder is where the actual script for the environment is loaded, and you activate it. And once you activate it, you will probably notice as a prefix on the same command line input, you will see there's the name of the environment itself. And if you do which Python 3 now, you can see that it points to the virtual environment Python installation. So now you definitely know that the Python version you are using is, the one from the virtual environment, unlike this one where, it's the system Python. So just to give you an idea, what I'm going to do is, let me just install something. Hopefully this won't take too much time. Yeah, so pip is the Python installer for libraries. It's not going to talk too much about it, but basically allows you to install any kind of libraries that are available. Yeah, so as you can see, it's installing. Until then, I'll just write some tester code. And I'm gonna be like, I guess numpy dot what was it? I guess py exists, not sure. Yeah, so hopefully I've installed the right environment. Yeah, okay, so I've installed it in the right environment. Okay, I think we can choose the environment here. You see it? It's here. Yeah, so once it finds it, probably that squiggle will go. Okay, so yeah, as you can see now, I have installed numpy in that environment, and if I try running this file, what's it named? Hello world. Yeah, as you can see, it prints hello world and 3.14 blah blah blah. But now the question is, what's the difference? Okay. So now if I go into the same repo, but if I try to run it using the system version of Python, as you can see, no module named NumPy, which means that NumPy was installed into my virtual environment's namespace and not the system Python namespace. So this avoids cluttering up your entire system Python. And as a rule, when you are working on projects, never install anything on your system Python unless it is something that will be used by every single project that you're working on. Okay. There are a few standard libraries which I tend to use across all my projects. One of them is Flask for making a web app. So it's kind of installed everywhere just in case I need to do some quick testing. But yeah, I usually never install anything else. It's usually very clean. Don't really install anything on the system Python itself. Make sure you work on just the environment and nothing else. So far, does anyone have any questions? Any questions? Is it straightforward? Okay, so no questions. Okay, fine. I shall move on. Okay, so now you're working on this environment. Okay, you have a particular version of NumPy installed. Now the thing is, you want your collaborator to also work with the same environment, because let's say you install NumPy and let's say you install NumPy version 2. Okay, just an assumption for now. You install NumPy version 2 and you tell your friend, okay, to run my project, you will also need to use NumPy. So what your friend does is he'll probably go and install NumPy again. But the thing is, you want to make sure that he installs the same version of NumPy as you, because at the end of the day, if he installs a different version, he will also end up with a dependency conflict when he tries to run it. So now, how do you exactly solve this issue? And as you have seen, you cannot really publish environments or rather commit environments to the repo. You shouldn't do that. So how exactly do you handle stuff like this? Well, the way you handle stuff like this is you set up something known as a requirements file. A requirements file is an easy way to sort of share environment specifications with your collaborators. Now, the way you do this is pip has a small functionality which is known as freeze. What freeze does is it kind of takes a snapshot of your environment and lists everything that has been installed on your environment at that point in time. So if you run it, it should show NumPy. Yeah. As you can see, we are using NumPy 1.2 20.1. So how exactly do you share the environment now? So you do the same command. And I'm not sure if you guys have learned about output redirection, but this is how you do it. A greater than symbol will basically redirect the output into a text file. And as per kind of conventions, as per conventions, it's always known as requirements.txt, which will kind of just copy paste the contents of the NumPy, copy paste the contents of the pip3 freeze command into the requirements.txt file. So as you can see here, it has kind of put it into this thing. Now the thing is, I'm just going to push to the repo again. Wait, is there a Git Ignore here? Why don't I see one? No? Yeah, so the reason I wanted to do this is because there's one VS Code folder. Yeah. So hopefully the VS Code folder should not get no .vs Code itself, right? Okay, I don't know why it's showing it's tracking. Okay, never mind that. This repo does not really matter. Okay, so just add all my changes now. Let's say add NumPy, let's say. Yeah, so oh god. Yeah, so let's say I've pushed my changes again and everything has been pushed. Okay, so now the thing is, how exactly will you actually manage environments and how will you make sure it runs? So I'm just going to quickly show you what you probably do. So let's say this is a desktop. Okay, I'm just going to move out of this. The git clone. Okay, no. What's the URL? Give me a sec. Let me just copy the URL. Yeah. Okay, so oh, by the way, do you guys have any questions? You can keep typing them in the chat. I can keep reading it. Okay, so what you do is assume this is someone else. Okay, this is not me. This is someone else. So what you probably do is, you know, I need to set that up. Okay, so assuming this is your friend who's also working on the same project, and I just cloned it again into a different repository name called test repo. So now I go into test repo, and if I do this, you can see there's a requirements.txt file, right? So now assume that this is your friend and he has just cloned the repo and he sees that there's a requirements.txt file. So now the first step your friend needs to do is set up the same environment. Now the way he will do this is he will first do something, he will need to obviously first create an environment itself. So virtual and test repo. env. So this will again create the same thing and activate, and this will activate it. Now if you do pip3 freeze now, you will notice that there won't be anything really installed in the runtime because there's nothing really there. So what you can do is you need to install the same libraries again with the same versions. But now the question is, how will you do it? I mean, you can't, this is just one dependency named numpy here. Sometimes you might have projects with, let's say, hundreds of dependencies. You can't copy paste them one by one, right? So pip has a nice functionality again. The -r form parameter kind of allows you to take in an input file of library names along with the versions. So the moment you do this, it will start installing numpy, and not only just numpy, it will install the okay, my bad. Yeah, so it will install numpy as well as the exact version of numpy that you had specified. Yeah, so it was cached in the system, so it just used the same thing. But as you can see, it's using the same version here. Yeah, this is what happens, if you just do pip3 install numpy. As you can see, it just says collecting numpy. When it says collecting numpy, is usually collecting the latest version of numpy itself, which will work with your system. So an issue will occur when you are using, let's say, an older version, let's say 1.15, but your friend decides to install libraries on his own and he just does pip3 install numpy. So your friend will probably end up with 1.20, whereas you're using a 1.15. Now usually a small change in versions does not create a big difference, but sometimes it can break your project. So yeah, just be careful about that, because as you can see here, it collects the exact version that is specified. If the version is not specified, it always points to the latest version. So that is it about the virtual environments. So if you want to deactivate the environment, I think the command was source deactivate. No, I think it was deactivate then, or I think it was virtual and deactivate. No. Oh shit, I created a new repo. Okay, fine. I've forgotten the thing for deactivating. It's something deactivate. But yeah, this is it for virtual environments. Do you guys have any questions about virtual environments? This is using virtual env, by the way. Python has its own virtual environment thing. It's called Python 3 Venv and Venv, I guess. Okay, I need to install that as well. Okay, it's just deactivate apparently. Okay. Okay, never mind. Fine. Fine. Okay, no, just deactivate. All right. So yeah, that is how you actually deactivate environments apparently. Okay. So that is it for virtual environments. If you want to go deeper into virtual environments, there's a very what do I say? A more robust virtual environment library known as PyEnv. Uh, PyEnv. PyEnv is extremely high level. It allows you to have different dependency versions. It allows you to have different Python versions as well. So every time you make an environment, you can actually specify the Python version, and it will kind of download that Python version and install it. So yes, it is a slightly heavy library to use, and in most cases, I don't really use PyEnv because it's not really required, and virtualenv does my part. There's also something known as pipenv. Pipenv is a more what do I say? A slightly better way to ship environments. It kind of creates something called a pip file and a pip lock file, which kind of locks your environment and does not allow anyone else to modify it. Again, not going to go into too many details about that. These are more complex virtual environment libraries which even I don't use. Anirudh, I think, uses PyEnv or pipenv, one of them. I use virtualenv because most of my projects, they work on the same Python version. It's just the dependencies which matter. Okay, so well, PyEnv manages Python version. Yes. Okay, so now what I'm going to do is I'm going to move on to the next part of our workshop. Before I move on, just a question: does anyone have any other questions about virtual environments? Anything about virtual environments, how to work with them? Okay, if you don't have any questions, we can just move on to the next one and install Notebook. Over here, Notebook refers to Jupyter Notebook. Notebooks are a nice way to run Python files. They are mainly used for stateful processing. By stateful, it means it kind of retains the state of the execution. Okay. It basically, when you run a Python script, when you click on F5 or Python3 filename.py, however you want to run it, it just executes the entire script and just moves on, right? So now the question is, what if you don't want it to move on, or rather you want it to sort of pause after the execution and wait, or rather you want it to, just be there with its state. You don't want it to quit. In that case, you need something known as Jupyter Notebook. Should have installed this before, but okay. Fine, yeah, just do pip3 install Notebook and it will install this. By the way, Jupyter Notebook also has a nice extension on VS Code, but I'll be showing it to you on the actual Jupyter Notebook on the web server. So yeah, this will have a lot of dependencies, as you can see. Jupyter Notebooks is one of the things that I installed on the system Python. That is why I deactivated it, if you remember. No reason why. It's just, sometimes you don't really need an environment to run multiple things. Just sometimes you need one file to see what's happening here and there. Okay, it's going to throw this warning if it's a new installation. It basically means that, some of the libraries which run on path aren't on your path. Okay, so I think this was the command. And what was it? Oh yeah, it was no hyphen. No, damn it. One second. Okay, apparently that was the right command. That's weird. Yeah. That's weird. Mm. Okay, I am not sure why this is the issue. Is it because of the path issue? Perfect. Okay, so now, okay, you know what? I'll just show it to you on Colab instead. It's the same thing. So, okay, so going to Colab. Okay, so just quickly, I'll show you how to exactly use a notebook. I'm not going to go in. Okay, I'm going to just quickly show you how to exactly use a notebook. Don't worry too much about what exactly is happening and stuff. As I said, a notebook is a nice way to kind of retain the state of execution while you're running stuff. Okay, so how does a notebook actually work? So as you can see, there is, you know, a black box here. This black box is known as a cell. Okay, so since this runs on Python, if you just do =2, it will execute that. So now usually if you just have =2 in a Python script and if you run it, it's just going to execute through it and not do anything else. But if you on a Jupyter notebook, okay, I think I should zoom in. Okay, so I don't know. So Jupyter Notebooks is going to look exactly like this. So don't worry about that. So if I just do A here, it will print the value of 2 because it kind of remembers the value. In a way, it is similar to the Python interpreter itself when you just do Python 3. The difference is it's kind of like a more structured way to actually handle stuff. Another thing which you can do is, the reason I want to show you is, let's say you have an array here. Okay, okay, so just 100. Okay, no. What am I typing? Yeah. So basically 1,000 zeros are there in the file. So, and now the question is, you have, let's say, a code snippet here, which takes, let's say, 10 minutes to run. Okay, so to give you an example, 10 minutes. Okay, you'll probably need something like a nested 3-layer loop. So let's say, and another 100, and let's say another 100. Okay, and all you do is, okay, how do I keep track of position now? Okay, okay, I'm just going to leave 1,000 so this will work. I don't need that. Oh god. Okay, so I can just do A of I is equal to A of I into okay, 2 plus 3. Okay, it's just a random thing. So hopefully they don't. Yeah, so this is going to take an insane amount of time to run because you have 1,000 into 100 into 100 kind of loop which is running. Okay, it happened quickly here, but if you increase this, it will tend to take longer. Yeah, so assume it's doing this multiple times. So now the question is, if you, let's say you have some simple statement after this statement. Okay, you have something, let's say B is also an array. So okay, I'll copy this over, same size. And what you do, B equals I plus. Okay, so now this code cell here is very simple to run because you know, what do I say? It just loops through the entire A array and kind of increments every element by 2 and stores it in B. If you don't know what list comprehensions are, it's like a shorthand way of doing a for loop. So but the thing is, let's say you want to change it. Okay, as you can see, this is still running. I'm just going to stop this for now. So let's assume this takes 10 minutes to run, and this will probably happen in a fraction of a second. If not a fraction of a second, just maximum 1 second. And let's say, you're like, okay, I don't want to increment it by 2 now. I want to increment by 3. I do it by 3. So now what happens? You might have to probably, run the entire thing again, because this will take 10 minutes and this will take, let's say, 1 second. So that's 11 seconds. But with a Python notebook, since this particular calculation is, okay, just remove this thing. Yeah, so since this calculation is happening only once, all you have to do is just run this again. Did you understand that? So, you just have to run this again and you don't have to run that again. Does that make sense? Okay. So yeah, that is it for now. We're not going to go too much into Colab and Jupyter notebooks right now because you don't really need much, but Jupyter is usually used to handle stateful processing here and there. Okay, so that is it for the end of the workshop. If you guys have any questions, redirect your questions to Anirudh. I kind of have to leave right now. So yeah, Anirudh, you can take over.
Yeah, guys, I'll be on for 15-20 minutes. So any questions you have, drop it in chat. Unmute yourself and ask. I don't mind either way.